Hi everyone, this is our second question from network theory. Here is the question. The switch S is closed at t is equal to 0. The rate of change of current d by dt of I of 0 plus is asked. We also have to calculate the power dissipated by the 3 ohm resistor at time t is equal to infinity. First, let us look at the prerequisites. So to understand this question, we should have a clear idea of the forced response of an inductor. At time t is equal to 0 minus, let us consider an inductor which is unenergized, that is, there is zero amount of current flowing through it and there is no energy stored in it. We know that the current flowing through an inductor does not change abruptly, that is, IL0 minus is equal to IL0 plus. So to maintain this condition, the inductor has to maintain the same 0 ampere current at time t is equal to 0 plus also. So the only way possible is to maintain an open circuit, that is, the inductor behaves as an open circuit at t is equal to 0 plus to maintain the same 0 ampere current at both t is equal to 0 minus and t is equal to 0 plus. And at t is equal to infinity, the inductor behaves as a short circuit because by then it reaches its steady state. The expression for the voltage developed across an inductor is given by V of t is equal to L dot di of t by dt. Here comes the current division rule. Let us consider a current source of value I amperes and having two resistors R1 and R2 connected in parallel across it. Then the current I1 is R2 dot I by R1 plus R2. I2 is equal to R1 dot I by R1 plus R2. Now let us go back to the question. In the question, it is mentioned that the switch S is closed at t is equal to 0. So at t is equal to 0 minus, this is the circuit where the switch is still open and this is an open loop formed here. So there is no current flowing through this part of the circuit. So we can easily say that the current flowing through the inductor at IL0 minus is 0 amperes. And as this is an open loop, this 8 ampere current directly flows through this 3 ohm resistor from top to bottom. Now let us analyze the circuit at t is equal to 0 plus condition. We know that the current across an inductor does not change suddenly. So it wants to maintain the same current at t is equal to 0 minus and t is equal to 0 plus. So as at t is equal to 0 minus, the current flowing through the inductor is 0 amperes, the same current will be maintained here. Current 0 means that it is an open circuit. That is why the inductor is behaving like an open circuit. We have already seen the same point in the prerequisites also. Now we know that this 8 amperes will directly come through this 3 ohm resistor because this is an open loop again. So 8 amperes. Now to establish the value for d by dt of I of 0 plus, we need to apply a KVL here. So let the current traveling in this open loop be I of t and the voltage developed across it be VL of t. So applying KVL, a point to note, IL of 0 plus is also 0 amperes. KVL, applying KVL in this loop, this I of t is traveling in a clockwise direction, so it is going upwards through 3 ohms. So I am starting to apply the KVL from this point. So 3 ohms into the current which is going up, which is I of t, minus the current which is coming down, which is 8 amperes, plus 7 into I of t, and here we have the voltage developed across the inductor, which is plus VL of t equating to 0. Now we are only concerned about the time t is equal to 0 plus because it is in the question it is mentioned to find the value of d by dt of I of 0 plus. So substituting t is equal to 0 plus in this equation, we get 3 into I of 0 plus minus 8 plus 7 into I of 0 plus VL of 0 plus is equal to 0. I of 0 plus is 0. I of 0 plus here is 0. And we know that VL of 0 plus is L dot d I of 0 plus by dt. So 3 into minus 8, this is anyways 0, plus L is 5 Henry. So 5 dot d by dt of I of 0 plus is equal to 0. From this, sending all constants to other side, we get d by dt of I of 0 plus, which is equal to 8 3s are 24, so it is 24 by 5, which is 4.8 ampere per second. The reason I'm writing ampere per second is this is the ratio of change of current by change of time. So it is ampere per second. Now let us move to the next part of the question. We are required to find the power dissipated by the 3 ohm resistor at time t is equal to infinity. Here we can see that 7 ohms and 3 ohms are in parallel. This is possible because the inductor has become a short circuit, because at t is equal to infinity, the inductor behaves as a short circuit as it has already reached its steady state. So we first need the current flowing through the 3 ohm resistor. So I of 3 ohms is, by using current division rule as already discussed in the prerequisites, the current flowing through the 3 ohms is 7 by 3 plus 7 into the total current 8. So this is 56 by 10, which is 5.6 amperes. Now the power dissipated by the 3 ohm resistor is as follows. It is the current flowing through the 3 ohm resistor squared multiplied with the resistor value itself. So I of 3 ohms is 5.6 amperes and the resistor's value is 3 ohms. So on calculating this, we get the power dissipated by 3 ohms at time t is equal to infinity as 94.08 watts. So this is the final answer. Thank you.